This is part two of the text mining example in R using Supreme Court case files and the tidy text package. I want to remind you guys that all of the resources for this illustration are available in a GitHub repository. Just go to github.com, Aaron Mams, look for the vignette text mining, and you'll find all of the resources to go through the code for this in part one. So we were looking at this step-by-step process for harvesting the text for one Supreme Court opinion from one PDF file that we downloaded from the supremecourt.gov site. And in the first video, the part one video, we got up through step two, which was bringing the data into the R workspace using that PDF_text method. And in this video, we're going to start in on the get markers step. And as I explained in the last video, this is the process by which I'm combing through the text and identifying the page numbers where the majority and dissenting opinions are listed in the documents. And what's going to be happening in this step is that I'm just going to be combing through the text of this PDF document to try to get the locations of the text that I'm interested in. And I'll be honest with you guys, this step is probably going to seem a little bit funky and a little bit out of place right here, mainly because I'm working with a single PDF document right now. But I'm going to ask you guys to kind of use your imagination and think about the challenges that we'd be faced with if we were trying to do this for a lot of PDFs, a lot of these text documents all at once. So this is going to seem like kind of an unnecessary step at the moment, but hopefully as we progress through this vignette, it'll become clear kind of why I did it this way. And now that I've talked that to death, let's go over here and just get started demoing some of this stuff. So I'm starting with a clean workspace, just so we can see everything that's going on here. I know in the last step, we already used that PDF_text method to get the text into the R workspace. I'm going to be doing that over again. So some of this will be a little bit repetitive. And there are a couple of libraries, a couple of packages that I'm going to be using here in this step. I'm going to make sure those are loaded in, and I will try to adequately describe them as I use them, okay? The first thing that I'm doing here in this step is just creating a derived data frame, creating two derived data frames. One of them is a data frame that I'm calling majority.find, and this is just a data frame that has a justice's name, and then it has that identifying text that we talked about from a few steps ago. We looked through the PDFs and we found that there were some unique text markers in there that kind of gave away positions of text blocks that I'm interested in. So for Justice Neil Gorsuch, anytime Neil Gorsuch wrote the majority opinion for a case on one of these PDF files, it will be identifiable by the phrase Justice Gorsuch delivered the opinion of the court. And so I have these identifying phrases in a data frame so that we can kind of iterate through them and we can look for this text, and we can find in any of these documents, we can find wherever the text is when Neil Gorsuch delivered the opinion of the court. You'll notice that I also have a little hack in here for Chief Justice John Roberts, because John Roberts is identified in the text of these PDFs as Chief Justice, not just Justice. That adds another word to each sentence that he's identified in. And in the case of this identifying text for delivering the opinion of the court, it means that whenever Chief Justice John Roberts wrote the majority opinion, that sentence gets split into two different lines. And so just for educational purposes here, I could identifying text. I could have made the identifying text for Chief Justice John Roberts. I could have made the identifying text for Chief Justice Roberts like this, because whenever John Roberts delivered the opinion of the court, whenever he wrote the majority opinion on one of these text documents, it's going to appear in the document like this, because the sentence gets split onto two lines. And so we could have done it like that. I chose not to. I went this hacky route that also works. And I suppose you guys can decide whether you like that approach or not. But at the moment, for the current purposes, it works. And I have the second derived data frame, descent.find, which is much like majority.find in that it has a justice's name, and then it contains the identifying phrase that appears as a page header whenever that justice wrote a dissenting opinion on one of these cases. Okay, and so we have those search terms, and the next thing that we're going to do is we're going to look for those search terms in the documents. In this case, I'm just going to stick with that one document that we imported last time, and we're going to look for those search terms in that document. So at this point, I have my search terms set up in these two objects, descent.find and majority.find. So these are kind of functioning as my lookup tables to provide the search terms that I want to search my PDF document for. The next step is to actually get that PDF document into the workspace. And one thing that I want to point out is that on this R script that I've prepared for you guys in the GitHub directory, I have this, what I'm walking through right now is actually wrapped inside of a function that I've written, and I'm just pointing that out, and I'm going to ask you to not get too hung up on that right now at this point, because these lines of code will run independently, and I'd like to just treat them as independent lines of code right now for this single PDF case, and just trust that I will explain the important elements of this function wrapper a little bit later when we move on to trying to do this for all 10 of these PDFs. Now, reading the document into the workspace, we're going to rely on this PDF_text method that we talked about, but unfortunately, I have to take a brief detour here and talk about this here function that I have nested within PDF_text. So here is a convenience function that comes from a package with the same name, and it is not critical to the illustration at hand, but it is something that I use a lot for defining file paths, especially when I'm working on code that I know is going to be shared. And so I'm going to show you guys what this does. Here is a function that defaults to the root directory of the RStudio project. So it's going to default to the top level directory in your project. And for me, that's kind of useful, and I'll show you why. So if I toggle over here to my RMD document that I have set up, and I run a line of, and I'll just insert a line down at the bottom of this RMD and show you what I'm talking about. We have, if I insert this line and I ask get WD, so what's the working directory? Right now, the working directory is the root directory for this project, and that's because this RMD that I have, text mining with Supreme Court, is in the root directory for the project. But you might prefer a different organization. You might say, well, I think that this would make a lot more sense if I went to the project directory and and I created a new folder for my RMDs, because maybe you don't like having all of these RMDs just hanging out in the root directory. And if we moved this RMD into that directory, RStudio is going to close it down. And if I open that RMD up now, and I insert this same line, now the R Markdown is going to default to the directory where the Markdown itself lives. And so now the working directory has these RMDs. And the reason this is going to seem like a really big buildup for a really small payoff, but this is something that's important to me, because the working directory now in this R Markdown is this RMDs folder. It prevents me from accessing files in other directories using a relative path. So I can't, if I want something that's in the data path, like I want to do a PDF underscore text, and I want to get PDF underscore text that's in the slip opinions, if the working directory were defaulting to the root directory for the project, I could simply put the rest of the file extension here. So I could start with data, SLIP 2019 18 9526 PDF, and I could run that, but because I've created this new file, I can't run that because it's not part of the working directory. So if I wanted to do that now, I would have to type out the whole first part of this file path that goes to the root directory. But if I use the function here, as I demonstrated before, here will always default to the root directory for the project. And so using here, I can use the relative file path for the data directory, and it will work out okay. Like I said, I know that that's a pretty big diversion for what might seem like a pretty small payoff, but for me, when I'm developing code that somebody else is going to run, here is a function that makes it a little bit easier for my code to be portable, and it makes it a little bit less likely that we'll run into file path issues with me hard coding a bunch of file paths throughout some documents. Okay, with that little diversion complete, I'm ready to do what I said I was going to do a few minutes ago and actually read the text of one of these PDF files into the workspace. So in my code here, I'm storing the name of the PDF that I want to read in as the object case. So let me go ahead and set that object value real quick, case, and I'll pass it the name of this PDF file, slip 2019-18 9526 underscore 9 PDF. Okay, and as I talked about just a second ago in that diversion, these files are contained in a directory called data. So if I paste that file name with that data path, I get this string here, and if I wrap that in the function here, here will append to it the root directory of the project. Okay, and so this is where R is going to go looking, and now I'll use that familiar PDF underscore text method, and I will pass it the file path, and I'm going to store that text in an object called doc. So I'm going to run this code. I'm going to get back my object doc. It's a character vector with 86 elements, one for each page of the PDF. And I'll just take a quick look at page 1 for no real reason other than I just kind of like to look at things after they get read in sometimes, and I don't want to print the whole thing because it's 86 pages of text and it's really huge. But at this point now I have the text from one of these PDFs into the workspace and I can start working with it. Okay, so once again, I have the PDF document read into the workspace. I have this object called doc, and that's the text in that PDF, all 86 pages of that PDF document read into the workspace. Okay, so the next thing, the next subtask in this step is going to be to find the page number where the majority opinion starts. And to do that, we're going to use this line of code here. But I'm going to make a brief diversion here because there's a lot going on in this particular line of code. And so I want to just demonstrate one feature of R for you guys, which is that you can nest functions within functions. And the way that I want to demonstrate that is to do something sequentially. I'm going to declare a date class variable called date1, and I'm going to make it a date. I'm going to make it August 1st, 2020, format %m, d, %year. Let's check it. Okay, date 1, and then I'll make another date class variable. I'll call it date 2, and I'll make this August 20th. And then I'll do a sequence of dates. Okay, and so what I did here was I did this sequentially. So first I declared a date class object here, and I set it equal to a particular date. I declared a second date class object, set it equal to another date, and then generated a sequence of dates from the first date to the second date. And all I want to demonstrate here, just an illustration for you guys, is that that can be done sequentially, but I can kind of skip a few of those steps, and I can do this in a single step if I want to by saying, so I can nest basically these functions. This date is a function as date, and I can nest it within this sequence, this date generating sequence seq.date. So rather than declare the variable first, I can just feed it in the same way that I did before. And then I need length dot out equals 20. And so rather than setting my objects first, my date class objects, and then feeding those into the date sequence function, I can nest these date generating functions as date inside of the sequence generator, and it works just fine. It works just the same way. So just a short illustration there to kind of show you how you can nest functions, because that's what's going on here. I have several functions that are nested within each other, and I'm going to work from the inside out and show you how the functions in here work together to detect the page on which the majority opinion for this PDF document that I've written into the workspace, or that I've read into the workspace, sorry, the page on which the majority opinion starts. Starting with the innermost function in this monstrosity here, str_detect. This is a string detect function. and it comes from the stringr package. So the stringr library has the function string detect, and this is a method that is going to look for a particular text string in a larger block of text. So I'm going to do this on the console for a trivial case, and then I'll show you how it works for the PDF that I've read into the workspace here. So if I have some text, and so I have a character vector, and if I want to search that for a particular term, string detect accepts the argument. The first argument is the string, so that's the text that we're going to look in. In this case, we're going to look in text, and then the next argument is pattern, so that's what string detect is going to look for. So I'm going to look for search term, so I'm going to look in text for the search term, and what I get back is a logical vector, true if it found the search term in that element of text, and false if it did not. So text has 3 elements. String detect is going to search all 3, and I'm going to get back a true false value for whether or not that search term was found in each of the elements within text. Okay, and so when I do that up here, okay, I'm doing it for doc is the text of the PDF that I've read into the workspace. I've wrapped this within a function, and I've done that because I want to be able to do this for basically all of the arguments in majority find. So if I just think about one element of majority find, so x, I'll set x equal to majority find phrase 1, and so x is now going to be the first of these search phrases in my lookup table here, majority.find, and if I do this string detect and I give it doc, so doc is the text that I want to look in, that's my PDF file, and x is what I want to look for, I'm going to get back a result vector that has 86 elements, 1 for each page of the PDF, and it's going to be true or false depending on whether or not that search phrase was found on each of these pages. Now, the next part of this function is that I've wrapped the string detect function inside of the which function. So which is a function that returns index positions, because what I would like to retrieve from this string detect is not a large vector of trues and falses. What I would like is the one page where it was found. And so if I feed the results of string detect into which, it will give me the index position of the true values. Right? So it found it on the 4th page of this PDF document. It found the search term. And so this is what I'm looking for. I'm looking for what page does the majority opinion start on. I know that the majority opinion starts wherever it finds one of these identifying phrases, such as Justice Gorsuch delivered the opinion of the court, and by wrapping the output of string detect in the which function, I get the index position. Okay, so one thing to note here is that which will give me the index position of all of the pages where this was found. So if I had some text where I had more than one true value, I would get back 2 index positions. So this is, this is a little bit idiosyncratic in that it works in this case because I know that these identifying phrases are found once and only once in these documents. So when these PDF files come in, I know that if it finds one of these identifying phrases for the majority opinion, I've done a fair amount of quality assurance and looking through these PDFs, and so I know it's only going to find it in one place. And so it's going to return me the page on which this majority opinion begins. Okay, continuing on our journey to find the page on which the majority opinion starts, I need to explain what this function piece is doing here. Okay, so I'll take this in 2 parts. So first, I'll write a function down here in the console, and I'll just give you a flavor for what that piece of the puzzle does. So I can call this anything. If I name something text find, and I call it a function, and it's going to be a function of some text, and what it's going to do is the same thing I have up above, which string detect in doc text. So it's going to return what we saw in the last step. This which string detect doc x returns me the index position where that search term was found. That's what this function is going to do. So it's just a slightly more general way to do what I did before. And since I have defined that function, I can use that function. So I can say text find. Text find is a function of this thing that I called text. And so if text is equal to majority find phrase 1, I'll get back the value 4, just like I got here. And so the reason that I've done it that way, as I mentioned a few times now, is because majority find. So just pretending for a second that we don't know, we've read in, so just pretend that we've read in one of these PDF files and we don't know who wrote the majority opinion or what page it starts on. And so we need to search all of these phrases because we know that the majority opinion will be the page on which one of these phrases is found. So we need to do this string detect doc x, this string detect text search term for each of these search terms. One way that we can do that is to have this function. So in this case, I have this function which is text find, and so text find will look for some text. And this is a nice general way to do this because now I can change this from the first of these elements here to the second. So majority find phrase second row is going to be Justice Alito delivered the opinion of the court, and I can use this to look for it, and it's not there because Justice Alito did not write the majority opinion on this particular PDF, nor did Justice Thomas, nor did, who's the fourth one? Nor did Justice Elena Kagan. And so writing this in a function kind of allows me to do this search repetitively, and that's why I've written it in a function here. And I'm going to use that function, I'm going to call that function for each of the elements in this majority phrase data frame. And so that's how I'm going to identify the location of the first page of the majority opinion. All right, I promise we're almost done with this line of code. I know I've spent a lot of time on this particular line. There's kind of a lot going on, and I'm trying to be thorough. Hopefully I'm not being overly thorough, but this is the last little step in this subtask here, which is to explain what this lapply wrapper is doing. So we went through string detect. It's accepting a text to look in and a search term to look for. It's returning a vector of output for each element that is in the text string that it's looking in. This which function whittles that down to the index position where the search term was found. The function is used in order to call this string detect repetitively for several search terms, and now this lapply method is the last thing we need to go through. So lapply, let's clean this up a little bit. Lapply is one way of executing repetitive tasks in R. So an alternative that many of you are probably familiar with would be to write something in a loop. So if I'm going to write a loop in R, I need to have something to hold my resulting values in. So I'll make result an empty list, and then I'll write a loop for I in 1 to 2. So I running from 1 to 2, and I'm just going to do this. I'm going to make the index position in result be the index value itself. And if I do that, I will have populated this list result with the values corresponding to the index position. Okay, really simple loop. And one alternative for doing this type of thing in R is to use lapply. And you can remember lapply as list apply because it's going to take values of a list. So you're going to give it a list, and you're going to apply the values in that list to a function. Okay, so function x, and in this case, x return x. Okay, so this is the same thing. It's going to feed the values in this list 1 and 2 into this function, and this function is just returning the value that was given to it, and you get the same result as if you had done this in a loop, right? So that's the lapply method, and here what I'm doing is I'm applying the values in majority find in the column phrase. So I know I've done this about 100 times already, but I'll do it one more time. And actually, just to make it, there we go. So this is the list that I want to apply to the function. As we saw in kind of the last subtask, the function is going to be a function which is going to accept some text, and it's going to search the doc. So it's going to search the text of the PDF that I've imported for the search term. And if I do lapply and I give it this list of search terms, it's going to execute this function for each of these values. So let's just go ahead and run it here and look at what majority is, and hopefully if I've explained these pieces correctly, it won't take much explanation for what the output of majority looks like. The output for this object majority is going to have 9 values, and each of these values is going to be the index position for the page on the PDF where it found the search term associated with this index. So there's 9 of these list values corresponding, one for each Supreme Court justice. Each Supreme Court justice has a search term associated with them. Those come from the values in majority.find in the column phrase. Okay, and the lapply method has fed each of those values into this function where I've used string detect to locate the identifying phrase. And because we're dealing with, at the moment, this one PDF document where we know that Neil Gorsuch wrote the majority opinion, the result of this lapply call here, right, gives me the index position where it found the identifying phrase for Justice Gorsuch, and it gives me empty values for everyone else because the search terms associated with these other justices were not found on the PDF that I'm looking in. Okay, so if we go one more step from there and we unlist these, then we have empty values for every index position in the list except the one where the majority opinion was found. So if I run this line, majority page start is 4. So that's the page on which the majority opinion starts for this particular PDF. And I know that might seem like a really roundabout way to do this because we went through the PDF and I showed you, and we opened the PDF and we saw that the majority opinion was written by Neil Gorsuch and it started on page 4. I know this seems like a lot of code to get there, but again, I'm kind of preparing you a little bit for the fact that we're trying to do this for a lot of these PDF documents. And if you think about reading in an arbitrary PDF document corresponding to a case file, we don't know which justice wrote the majority opinion and we don't know what page it starts on. So we're going to search all of those identifying phrases, and then by using those identifying phrases, we're going to find the justice who wrote the majority opinion and the page on which it starts. In this case, it starts on page 4, and I've assigned that to a value, majority.page.start. Okay, so now I have the page on which the majority opinion starts. The next step in this little algorithm here is to get the justice's name that is associated with that majority opinion. And so at this point, it's probably a good idea to pause and just give you a little bit of a review of why I'm doing this. This whole thing that I've got here called get markers, the whole purpose of this exercise is not to get the text of the majority opinion, it's to create a lookup table for the locations of where these things are. And the reason I'm doing that is because I know in my head that down the line, when I want to go to analyze some text, what I would like to be able to do for a big bundle of PDFs corresponding to these cases, I would like to be able to ask my code, okay, can you get me all the text for all of the majority opinions from 2019 written by Justice Clarence Thomas? And I would like to have an efficient way to do that. And so the way that I have come up with to solve that problem is to develop this thing called get markers, which is going to create a big lookup table. And so now that I've got the page on which the majority opinion starts for this particular document, I want to add to that the justice's name who wrote that majority opinion so that the output from this get markers exercise can be a large data frame that has a lookup table, and it has a justice's name and the page number on which any majority or dissenting opinions started and ended. So that was quite long-winded, but I felt like it was a little bit necessary. Let's dive into it here and just show you what's going on here. I've got an object called majority author index, and what I'm doing with this is just trying to get the justice's name. So I have this object called majority. It's a list, okay, and the list is holding the page number on which the majority opinion starts, and each element of the list corresponds to a justice from the data frame majority find. And so what I'm exploiting here is the fact that if I use this length on a particular argument in majority. Majority is a list, and the length of the first element in that list is 1. If I use length for the second, it's 0. For the third, it's also 0. So for each of these list elements that are empty, they will have length 0. And so what I'm looking for here is the item, the list element in this object majority, which is not 0, because that's going to be the list element corresponding to the justice who wrote the majority opinion for this case. Okay, and so again, if I wrap this in a function and I give that function all of the elements in majority, it's going to evaluate that condition, length x greater than 0 for each of those. And so why don't I do this innermost portion here. So lapply, so apply a list. The list is majority to a function. The function is a true-false value for whether or not the length of that element is greater than 0. Where does this go to? There we go. The lapply ends there. So lapply to majority. That lapply, right, evaluates the length, okay, and then unlisting the values where that length is greater than 0. Let's see. Unlisting those turns that into a vector. And then once it's been coerced into a vector, which will give me the index position for whichever of these elements of this vector now are greater than 0. So the index position for the author is 1. So then the author is the element of majority.find corresponding to that majority author index and in the column justice. So in this case, I didn't actually run this to get that. So in this case, the majority author is Neil Gorsuch because the majority author IDX is 1 and majority.find the justice name for that index position is Neil Gorsuch. Okay, so at this point now I have found the page on this document where the majority opinion begins, and I have found the justice who wrote that majority opinion.